This is how I first tested the code, blinking a few set of LEDs by making the first circuit on a breadboard. The PD driver output can cycle through different voltage level by pressing the onboard switch ranging from 5 to 20 volts. Welcome to Altium. This video is proudly sponsored by Altium. If you are serious about PCB design, Altium Designer gives you everything you need, from schematic capture and PCB layout to powerful 3D visualization. If you are a student looking to build professional PCB design skills, this is an incredible opportunity. You can get free access to Altium Designer, hands-on PCB design courses, a cloud workspace, and you can obtain an industry-recognized certificate to showcase your skills. Here is my schematic of this PD module. First comes the input section, which is basically a USB Type-C connector. Then comes the LM317 adjustable voltage regulator for the 3.3 volt microcontroller power. Here is our main PDIC with the decaps and PD power good indicator. Then a set of LEDs and configurable resistor with a switch all have to cycle through the different voltage modes. All these parts are controlled using a low-cost 32-bit RISC-V MCU. Finally, on the right side we have a voltage output connector. Here comes the PCB. First the USB Type-C, then our PDIC with a power good indicator. Next to it there is a voltage regulator, then decaps and the potentiometer for voltage regulation. Then the LED voltage indicators, switch and main microcontroller. Behind the MCU, on the bottom layer there is a one exposed copper pad for programming. I have designed to keep the form factor small. It is a two-layer board with components on the top layer and just one programming pad at the bottom. I fabricated 5 of them. Here is the first look at the PCB, silk screen, pads and finishing. Overall, everything seems good. Then I assembled one of them. There is a one missing connection which I corrected in the shared files. Just one note here. Before soldering the MCU to the PCB, first adjust the LM317 regulator to 3.3 volt. Otherwise the MCU will burn out from the high voltage. Here comes the programming part. The MCU CH32V can be programmed through Mount River Studio. The code files are shared in the description below. The code is very simple. Just go through that for the programming. First, connect the board, then build the code base and hit download. It will automatically flash into the microcontroller. Here is how I carried out the first test of this code. I mounted the dev board with some LEDs and a switch to check the functionality. I have one USB meter laying around which I used to turn it on for the first time because it supports PD protocol. I have some PD and PPS chargers. One is from my MacBook and other is from board. This 67 volt charger comes with many features and supports 20 volt, which I used in my test. You can also use the MacBook one because it also supports the same protocol. Here is the basic setup I made to test the current and voltage. The USB meter sits in the middle, so if any shorts occur, it will automatically turn the system off. The power supply starts 5 volt with idle current of 8.4 milliamperes, and now I can test the PD functionality by cycling through different voltages. Everything works fine, so I connected the charger directly and multimeter in the voltage mode, and you can see all the voltages cycling with LED indicators. Say if the charger voltage does not support 20 volt, it will keep the voltage at the previous level, which is 15 volts. It is always start from 5 volt. You can enhance the functionality later using EEPROM. So that is all from my side. Hope you like this project. Comment your opinion below.